everyone, welcome to another video. Today we're going to talk about a very important concept which is called the graphical solution. This will be chapter 5, and this is one of those things that a lot of people don't understand. They do maths all their life, but they never understand what on earth is happening. So today is my attempt to really get this core concept into your brain. Okay, so here we go. So let's start with a line. See, it's a y equal to x plus 2. Okay, so you can see that I've already drawn the line for you. So this red line is the graph of y equal x plus 2. Okay, so let's consider the following points over here. See, I have A, B, C, D, E, F. So 6 points. So you need to label them. So I've labeled them already. See, A, B, C, D, E, F. So what I'm trying to illustrate here is, let's say for point A. So point A is over here, it's on the line, right? So if I sub point A, which is x equal to 0, y equal to 2, into the line y equal to 2x. Okay, so I'm going to sub x equals 0, y equal 2. So over here is x equals 0, y equal 2, then plus 2 from here. You see that the equation becomes 2 equal to 2. So this equation is what we call satisfied. That means this equation holds true forever. That means 2 is always equal to 2. So we are fine. So if you look at the point B is the same case. Point B is over here. Okay, so over here is negative 1 and 1. So if I sub x is negative 1, y is 1 into the same equation of the line, you notice I get 1 equal to 1. So it's the same for point F. Point F is also on the line. Eventually I get 8 equal 8. But let's look at a point that is not on the line. So for example, point C. See, C is over here. If I sub 1, 1 into the line, eventually I get 1 equal to 3. And 1 is never equal to 3. And so the equation is never true. And that is why I say this equation is not satisfied. Okay, you see the trend here. For point D, so over here, point D is here, also not on the line. So if I sub, I get 7 equal to 5, which will never be true. So it's also not satisfied. So you can see that the trend is very obvious. Point A on the line, satisfied. Point B on the line, satisfied. But point C, not on the line, the equation is not satisfied. So point D also not on the line, not satisfied. So the final conclusion of this whole story, after this long story I'm telling you, is that only points that satisfy the equation lies on the graph. Okay, this works for any graph, doesn't have to be a line. Any graph, some sort of curve, cubic, whatever, it all works. Okay, so the conclusion is also here. The graph of y equal to 2x represent the points that satisfy the equation. Anything that is not that doesn't satisfy the equation is not on the graph. Okay, so this is the true meaning of what a graph really represents. The points that satisfy the equation. Only the points. Anything else cannot. Okay, so with this, let's move on to the next part. Graphical solution. Okay, so I'm going to do two things here. This is your, on the left side, I'm asking you to solve the equation simultaneously. So this equation and this equation to solve simultaneously. So usually I like to sub. So I'm going to sub 1 into 2. Okay, so I sub this into this, I get x plus 2 equal to negative x plus 6. Okay, so if I delete this hidden box, you will see that from here, I'm just going to move the x over, move the 2 over, I get this, the x equal to 2. And then I sub x equal to 2 into the first equation here. I get y equal to 2 plus 2, so y is 4. So at the end of the day, the solution is x equal to 2, y equal to 4. So this is basic simultaneous equation. But what happens is, how does this look like when we do it graphically? Okay, so first, let's try to plot this graph x minus 6, negative x plus 6, sorry. Okay, so typically we need 2 points to draw a straight line, right? But typically we want to be kiasu, we use 3 points in case we make a mistake. So from here, let's try 0. So if I sub x equals 0, I'm getting y is equal to 0 plus 6. So the point is 6. So similarly, if I sub 2, I'm looking at negative 2 plus 6. There will be 4. And then if I sub 4, there will be negative 4 plus 6. So there will be 2. And after that, I'm going to plot these 3 points. So 0, 6 is 1 point here. 2, 4, 2, 4, this point. And then 4, 2. So 4, 2 is 4, 2. So these 3 points I'm going to join, and I'm going to form this blue color line. Okay, so and you notice that I also highlight this intersection point. So later, let's talk about this later. But let me scroll down a bit. And you notice that over here, we are solving this equation x plus 2 equal to negative x plus 6. You notice that this red line is the same line we draw just now. If I scroll it up, you can see this red line is the same line. This is the line x plus 2. And then this blue line that we just draw is negative x plus 6. So what happens is I'm drawing the red line and then I'm drawing the blue line. And when I solve this equal to this, so when I solve the red line equal to the blue line, you notice that the answer is actually 2, 4. And this point over here is also 2, 4. So this point is 2, 4. And that is actually the intersection point between the red graph over here and the blue graph over here. Now this is not by chance. Let's be clear about this. Nothing in maths is by chance. So what happened is, when I solve this equation, I draw the graph on the left, I draw the graph on the right, and the two graphs will intersect at the solution. You see the solution 2, 4, the intersection point 2, 4. Okay, so this is the most important conclusion that you must get from when I solve an equation. I can draw the graph on the left, I draw the graph on the right, and the answer to this equation will be the intersection point of the two graphs. Okay, so this is the real meaning of graphical method. With this, there are many questions that you can solve. So let's end here today. So hope you have learned something new. Thank you and bye-bye.